All right. So piecewise functions. You may hear them called piecewise defined functions. They're functions that have pieces, and there are definitions for what's going on in each of those pieces. So a piecewise function is a function that's got different parts. Okay, so let's just start with the first example. F of x, it's a function, so we're using function notation. F of x is the same thing as what? Y. That's all it means. Y equals f of x equals. And then they put this little curly brace thing there. And everything that's in here is what makes up this piecewise defined function, or piecewise function. Okay? So we're not going to get into too complex of parts, nothing like what you'll get into in college algebra, where the pieces of the piecewise defined function are a little bit more extensive. What we're going to deal with is linear pieces inside of these piecewise functions. So graphing a line, we've been doing that for the last week or so, so that's shouldn't be anything daunting. So the first piece is going to be 2x plus 3, and then they put a comma, and then they tell you this is where this happens. This happens when x is less than negative 2. Okay. So that's piece number 1. Piece number 2, negative 1/3 x, and then the comma, and then they're going to tell you where does it look like negative 1/3 x. It looks like that from negative 2 less than or equal to x less than 3. That may be the most complicated part, because it's got a kind of a tougher looking inequality there. Then the last piece is 2x minus 1 for x is greater than or equal to 3. Okay. So 3 pieces in 3 parts of the graph. Okay. So when we draw this, we're going to draw 3 pieces when we graph this. Those pieces are determined, like where it's going to happen at, are by these inequalities. Okay. So as you're doing this, you go to draw that graph. Maybe just a coordinate plane there. Each piece needs to be done kind of separately, is the way you want to do it. That makes it the easiest thing. Some of you can think about all of it at once. You've got that mathematical mind, that being able to visualize things a little bit better than some others. But for the most part, if you'll just do them one piece at a time, they're not real hard. So let's look at this first one. The first piece is 2x plus 3 when x's are less than negative 2. So what it's saying is we're only drawing that graph when x is less than negative 2. So what we have to find with each piece are the important points. The important points come from the inequality. So at negative 2, what's going on with that graph? Where's it at? How can we find out what's going on at negative 2? We can plug it in right here. Okay? So important point would be at negative 2, and then plug in that for x. So negative 2 times 2 would be negative 4. What's negative 4 plus 3? Negative 1, right? So there's an important point at negative 2, negative 1. So here's where I've got to think a little bit more. What does this inequality tell me about negative 2? If it's just less than negative 2, is negative 2 included in this inequality? No, it would have to have what on it to be included? The little bar underneath it to be equal to, right? And so this point, it's part of the graph, but it's not included. Okay? So when we go to draw that, we're going to put an open circle there. Instead of putting a dot to say that point's there, we're going to put an open circle at that place on the coordinate plane. So we're going to go to negative 2, negative 1, and we're going to put an open circle right there. Doesn't have to be real big. Just make sure it's easy to see that it's open. From there, I want to go where the x's are less than negative 2. So that would be which direction, left or right? Yeah, back this way, right? So this problem looks like 2x plus 3, which is a slope-intercept form equation, right? What's the slope of that line? 2. It's the number in front of x. So we need this line to go this way, but with a positive 2 slope. So how do we count that from this point? Up 1, left 2 would be a negative slope because it's going that. We want a positive 2 slope. Should it be going up to the right? But we want it to go this direction. Positive down 2, back left 1. And that's a positive 2. Negative 2 over negative 1, that's positive 2. So that you can count that slope that way. You can count it again, and you get this picture going on. That line going that direction. Has an arrow on the end because it says all the x's that are less than negative 2. So it keeps going this way. Okay? Another way of doing that would be pick an x value that's less than negative 2 and work and plug it in. So like negative 5. That'd be negative 10 plus 3 would be negative 7. So at negative 5, I could go down here. There's negative 7. That's the point on the graph. So you could plug in x values if you want to. I'm a count slope kind of person. That's the way I do it because that's the way we've been doing it. Okay. So you just got to think, okay, how can I count the other direction? If you remember, we did that a lot when we were doing the absolute value graphs and the equations of lines, the systems of equations with that. Now, that's piece number 1. We got 2 more pieces to go. Piece number 2, look at its inequalities. It's more complex, right? How many important points do you think this inequality is going to get us? 2, because there's how many numbers there? 2 endpoints. Okay? So we want to take these and plug them into that part and get the 2 important points that go with that. So I'm gonna draw this one in red. So I'm gonna use these. Negative 2. If I plug that into negative 1/3 x, that would be positive 2/3, right? And then 3 plugged in would be what ordered pair? What's the y value that goes in 3? It goes in here. 3 times negative 1/3 would be negative 1. Now, which one of those is not included? Why? Not an equal to mark on the 3. So we know this point is going to have an open circle on it. So I could go to 3, negative 1 and put an open circle right there. At 3, negative 1. At negative 2, 2/3, I'm going to put a what? Closed circle. Or just a dot. That'd be about right there. We're around there. It's a straight line, right? Can I just connect those two? It should go up 2/3. Yes, thank you. Thank you. Right there. Sorry. Now, if we think about the slope of that, connecting those is going to be down 1 over 3, down 1 over 3. But we're just going to stop right here at this open circle. So it's just going to be this line that connects those two. I'm going to use a straight edge so it looks a little bit better. There's piece number 2. Piece number 3. Get the important point for piece number 3. What's the x value of the important point for piece number 3? It's 3, because that's the number that's in the inequality. I'm not pulling those out of nowhere. I'm getting them from these, and they'll be given to you. Okay. Now, what's the y value that goes with that? 5. Okay. 3 times 2 is 6. Minus 1 is 5. So is that point included or not? Yes. So it's going to be what kind of dot or circle? Closed. Yeah. Filled in. So we're going to go to 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. I'm going to put a filled in circle there or dot. And now it's going which direction? Yeah, up and that way, right? Because it's greater than 3. So all the x values are going this way. So we're going to go up 2 over 1. So I'm going to put a dot there and leave myself enough room. I could do that again if I wanted to. This graph is the graph of that piecewise function. Yes, ma'am. I plugged in this 3 to 2x plus or minus 1. 3 times 2 would be 6, and then subtract 1 is the 5. So I'm always going to take these numbers that are out here and plug into this piece over here to get that important point. Yes, ma'am. Yes, that's a very important point. She said if you got 2 points, you won't have arrows. That's true. If you've got 1 point, you should have arrows going whatever direction that part's going on. This is a closed circle right here. Open circle here, closed here, open there. And it's not necessary, you're necessarily always going to be one open, one closed, one open, one closed. That changes according to the inequality. So we just have to go by the equal to mark or not on there to decide that. Okay, so you're not always going to have open circle, closed circle kind of stuff. So we've drawn the graph of our first piecewise function. Okay. One's not enough. Let's do another one. See if we can feel a little better about it. Let's call this one g of x. And let's do negative 3 over 2x minus 1. X is less than negative 2. And then let's do x plus 1 from negative 2 less than or equal to x less than or equal to 1. And then 3. X is greater than 1. All this stuff will be given to you for you to graph with, okay? You won't have to come up with any of that stuff. Now, start with the first piece. What do we do first? Good. Plug in negative 2 for x and get that y value that goes with it for that important point. So negative 2 times negative 3 over 2 would be 2. No, it would be 3 minus 1 is 2. Yeah, that's right, 2. Final answer of 2. Is that included or not? No, because it's got what kind of symbol there? Just a less than, no equal to mark. So when I go to graph that, I'll make sure I leave myself enough room here. I'm going to go to that point, negative 2, positive 2. I'm going to put open circle. Now, how do I go from there? Down 3 over 2. But am I going to the right? Because it says x's are less than negative 2. So which way should I be going? Back this way. So down 3 over 2 is how we would normally count that. We've got to think the other direction. So I would go up 3, left 2. Be the same line, it's just going to be this direction of it instead of that direction. Okay, so up 3, left 2. And I'm going to connect that. Should I put arrows on this one? Why? Because there's only 1 point, and those x values keep going less than negative 2. They keep going this direction. X and y values keep going up. X values keep going to the left. Okay. Piece number 2. First important point. -2, -1. Second important point. 1, 2, right? Are both of those included, or one of them included, one not, or neither of them included? Both of them have a closed closed circle, because they both have an equal to mark. Okay. So at -2, -1, closed circle, and at 1, 2, closed circle. If I just want to check myself to make sure I did it right, I can count my slope between these two and make sure it's 1. Up 1 over 1, up 1 over 1. Up. Yeah, it works. Okay, that's a good checking spot. Just count your slope like you normally would from this point to this point and make sure it matches that slope that's there. If it doesn't, something went wrong when you plugged it in, or when you counted your slope, one of the two. Okay. So here we have piece number 1, piece number 2. Let's find piece number 3. And this is the one some folks get confused about. The x value for the important point is 1, right? We get that from here. What's the y value? Why 3 and not 0? If we think about just this part of the equation, we kind of ignore the top part. G of x is equal to 3 is like what equals 3? Y equals 3. That's where that's coming from. So we got y equals 3 for any x value greater than 1. So the important point is at 1, 3. Is that open or filled in? Why open? No equal to mark. Okay, so 1, 3, open circle. Now what's the rest of the graph look like? Y equals a number. Straight across, horizontal, and it goes which direction? Go back to the left or to the right? To the right, because it's x values that are where? Greater than 1, so it's going to go this direction. So it's a horizontal line. Does it have an arrow on the end of it? Yes, absolutely. You do a very good job getting that. So not too bad. It's a little tedious. You got a lot of little pieces to do to come up with something this simple looking, but one piece at a time to build the piecewise functions. Okay. Questions about this one? All right. Let's look at maybe not graphing one, but actually doing some function work with it, some function value works. So find the function value. And here's our function. It's a piecewise function. Or better yet, let's do a non-piecewise first, just to make sure we remember how to do that. 3x minus 9. Let's find f of -4. What does that mean? Anybody remember? Okay, yeah, you replace the x's in the problem with the -4. That's all that means. So it's just find the y value for x value of 4. So, or -4 in this case. Work that out. Be -12 minus 9 is -21. So f of -4. What that accounts, to is the ordered pair -4, -21. That's what that means. This is function notation. This is ordered pair notation. Algebra, geometry. That's the difference. I mean, really, that's about it. Algebra world, graphing it on a quarter plane world. That's the difference in those two. So just take this value, plug it in for x in the problem. Now, where it gets a little bit more complicated when you're dealing with piecewise defined function, you got to deal with a little bit more stuff because you got pieces. And we'll just take a pretty simple one here. And let's find g of -4 for this one. Kind of the tricky part here is, well, where does it go? Where does -4 fit? In the first piece or the second piece? And why does it fit in that one? Can't go in both of them, because that would be two different x values. And the rules for functions are you can't repeat your x's. Be two the same x value twice, right? And you can't, if you're a function, you don't repeat your x's. Tell me why you think that. Okay. Anybody think it goes in the top one? And can give me a semi-valid reason for why you think that. Think about what the -4 is. What is the -4? Kind of value is it? Well, it's a negative one, but it's also an x or a y. It's an x value, right? We're plugging in for x. Where are the x's negative? Why the top one? Because it's less than 3. Is -4 less than 3? Yes. So if -4 is less than 3, then we got to use the top one. So we got to figure out, that's what we have to do if we're doing function value with a piecewise, is we look at this x value and say, okay, where does it fit? Well, is -4 greater than 3? No, that's false. That doesn't work. Is -4 less than 3? Yes. So that's the one I want to use. I'm going to use the first part. So I plug that into 9x minus 4 and work that out. So that'd be -36 minus 4, which would be g of -4 is equal to -40. What if I ask you to find, same problem, not going to write another function here, just let's do g of 6. Where do we plug the 6 in? Why the bottom? Yeah, because 6 is greater than 3. So we're going to plug that in there into this and work it out to get our y value. Okay, so it's dependent on where this fits in the inequalities with piecewise. Okay, so we're going to plug that in to -3 times 6 plus 2. So g of 6 be -18 plus 2 would be -16. Is that right? You're welcome to check me with the calculator if you need to. Try not to use one if I don't have to. But let's find another one. Same function, nothing changing there. That way you don't have to, change the rules here. You'll think a little bit. Let's do f of 0, or g of 0, not f. Sorry, I gotta rename that. G of 0. Why the top? Yeah, 0 is less than 3, so that's why we're going to use the top function. So 9 times 0 minus 4, which would be -4, right? One more, the hardest one. G of 3. Why? Y'all answer that. That's the piece. Because it's equal to, right? And the bottom one has the equal to mark. So that's where we're going to go. -3, 3. So that'd be -9 plus 2 would be -7. All right. Believe it or not, your homework only has 5 questions on it. but each one has much more. Huh? Friday, you want my phone? You shouldn't have homework today, because you should get done. Yeah. All right, guys, when you look at this, you'll notice each of the problems is kind of a combination of everything we've done. Number one, there you got a grid over there to the right to graph it on, to graph that piecewise function. And then underneath, evaluate the following, that belongs to number one. As you're evaluating some function value and graphing, just like what we did in notes there. And then number two, same thing, going through there. Three, same thing. Four, very much the same thing. Number five is the kicker. That's the challenge problem. You've got the graph, write the piecewise function from it. Okay? So if you can get through 1 through 4, and then see if you can put your heads together on 5, just to see if you can get there. Yes. Yes. Yes, sir.
This one has the same points as 2 over 1 equal to 1 not. So how will
They'll just be right on top of each other. So kind of like put your solid dot inside of an open circle, kind of like that. If they land on the same spot, something like that. Solid dot inside of an open circle. That just shows me that you got both of them.